The objective is to solve a nonlinear system of equations by substitution. You have to get a variable by itself. It could be any one of those four listed up there, but pick the easiest one. And the easiest one is going to be the one that doesn't have an x squared in it. 2x plus y equals 10. The easiest one to get by itself is y, because you only have to move 2x to the right and change the sign. This expression is equal to y, so you should be able to put it here in the other equation. Instead of x squared plus y, you're going to have x squared plus the quantity of negative 2x plus 10. And set that equal to 13. Get rid of the parentheses. In this case, you just have a positive sign here, so you're just multiplying everything by a positive 1. X squared minus 2x plus 10 equals 13. So now we have to simplify this as best as we can. We have x squared minus 2x plus 10 on the left, but that 13 goes to the left and changes signs. And then you would have to do 10 minus 13, which is minus 3. You can use completing the square, the quadratic formula, or factoring to solve this. We've been over all three of those. This one is factorable because you can multiply to get a negative 3 and add to get a negative 2. So that would be x plus 1, x minus 3. Set each of those expressions equal to 0 and then solve them to get x equals negative 1 or x equals 3. Now you have to use the negative 1 and the 3 back in one of these equations up at the top to solve for y. I'm going to use 2x plus y equals 10. 2x plus y equals 10, and I'm going to insert the negative 1 that we found for. We'll plug in the negative 1 for x, so it would be 2 times negative 1 plus y equals 10. That's a negative 2 plus y equals 10. So 10 plus 2 is going to give me a value of 12. That means I put in a negative 1 and got back a 12. So I have negative 1, 12. Now I have to use the 3 that I found for x. We've already used the negative 1, so we're going to put in the 3. And we're putting that into 2x plus y equals 10. That's from the original set of equations. So that would be 2 times 3 plus y equals 10. 6 plus y, not 4, but 6 plus y equals 10. Y equals 10 minus 6, so y would be 4. We put in a 3 and got back a 4. So your solutions are negative 1, 12, and 3, 4. We want to get a variable by itself. You can choose either equation, but it's easier to start with the one that doesn't have a second power in it. So at the top, we can try that. We can try this equation here, and we want to isolate something from that. You can choose the x, you can choose the y. I'm going to choose the y and be left with negative 2y on the left, moving the minus 3x to the right, making it positive 3x, and then minus 11. To get the y by itself, you have to divide everything by negative 2, so that leaves me with a negative 3 halves x plus 11 over 2. Now this would have to go into the other equation here for y. So we're going to use that and go here. X squared plus 3 times y. We're taking out y and putting in negative 3 halves x plus 11 over 2. And then setting that equal to 19. Now you have to simplify, taking away the parentheses. X squared plus, you could put plus a negative 9 over 2, but then simplify the signs later. And then 3 times 11 over 2 is 33 over 2 equals 19. Of course, you don't have a plus minus in your problem, or plus a negative. Just make it x squared minus 9 halves x plus 33 over 2 equals 19. We want to try to create a quadratic equation if we can. So x squared minus 9 halves x plus 33 over 2, and then move the 19 to the left and make it minus. Of course, we have to combine 33 over 2 minus 19. An easy way to do that is to keep everything else the same and get a common denominator, which would make this 38 over 2. Multiply 19 by 2 and the bottom by 2. So that when you do that, you're left with x squared minus 9 halves x minus 5 over 2 equals 0. Factoring this probably wouldn't be too much fun, and the quadratic formula, though with a calculator, is still easy. But I think we could do this better with completing the square. So if we try to complete the square on this, remember you have to do x squared minus 9 halves x and move the minus 5 halves to the right and make it 5 halves. The next step is half of the middle term, square it, and then add it to both sides. Half of the middle term is 9 over 4, and then you square that and add it to both sides. So we're going to have negative 9 over 2 x, and 9 over 4 squared. So half of 9 over 2 is 9 over 4, and if we square that, that's going to be 81 over 16. And then you're going to add that to the right side as well. So we have to have our perfect square on the left, which is going to be x minus 9 over 4, quantity squared. And then on the right side, to get a common denominator of 16, we have to multiply the 2 by 8 and then the 5 by 8. If you multiply 5 by 8, you get 40, and add it to 81, you get 121 over 16. So now you need the square root of both sides to come up with x minus 9 over 4 equals plus or minus 11 over 4. And you have two problems to do. X minus 9 over 4 equals 11 over 4, and x minus 9 over 4 equals a negative 11 over 4. So if we do the left-hand side, x equals 11 over 4 plus 9 over 4, which is going to be 20 over 4. That gives me a value of 5 for x. And then on the right side here, x equals a negative 11 over 4 plus 9 over 4. That's going to be a negative 2 over 4, which will be a negative 1/2. So now we're back up here at the top, and we have to use those values of x into this equation, and that is negative 3x minus 2y equals negative 11. And the first value of x we found was 5. So we're going to put 5 in for this one and get negative 3 times 5 minus 2y equals negative 11. That's a negative 15. Minus 2y equals negative 11. Keep the negative 2y on the left and move the minus 15 to the right. Change the sign. Come up with a 4. And then divide 4 by negative 2 to get an answer of negative 2. So we put in a 5 and came back with a negative 2. There's one solution. And we're going to use that same equation again. Negative 3x minus 2y equals negative 11. And insert the negative half this time. So here's a skip in the video. I forgot what place I had moved it to the screen. But anyway, we're putting in a negative half for x. And that negative half goes here. We're solving for y. We come out with a positive 3 over 2 minus 2y equals negative 11. Negative 2y equals negative 11 minus 3 halves when you move it to the right. And you have to simplify. Negative 11 minus 3 over 2. If you make that with common denominators, then you'll have a negative 22 over 2 minus 3 over 2. And that's a negative 25 over 2. So now you're going to have y equals a negative 25 over 2 divided by a negative 2. Anytime you divide by an integer, it's the same as multiplying by the reciprocal. So you're really multiplying by a negative half. And that would give you a positive 25 over 4. If you change it to a mixed number, you'll end up with 6 and 1/4. So we've put in, for this one, a negative half and came back with a positive 6 and 1/4.